Here's an example in how to read a data output for linear regression. Here we're talking about predicting a grade in class based on where they sit in the classroom. On the left is a residual plot. I see a random pattern that indicates a linear relationship, so that's a good thing. But yet look at the plain old scatter plot. I don't see anything there. I mean, maybe it has a slight negative trend to it, but those dots are all over the place, look almost just like the residual plot. The scatter plot right here is more important than the residual plot. All right? So even though the residual plot looks good, the scatter plot, I don't see anything there. But let's look at the data output below this. I'm more concerned about that for this problem. That's why I picked it. Because you need to know how to find the least square regression equation. R squared, and S, the standard deviation of residuals. So the row that says, or the line of data that has your X context. So notice the X context is row right there, and the Y context is score. That makes this the slope information. And more specifically, that is the slope. The line of data that says constant, that is the y-intercept info. And more specifically, that 85 number is the y-intercept. So the reason why I say info is because just to the right of it are these other numbers called standard error, and then T, and then P, but we'll deal with those in the spring. So standard error, T, P, that's for hypothesis testing to check if it's a significant slope. This number right here down the road we'll check to see if it's smaller than 5%, and if it is, that means it's significant. Obviously, this one is not smaller than 5%, so it is not significant, which kind of goes along with what I was saying a second ago about the scatter plot and how I don't see anything there. It's just random dots. So not much of a slope. Obviously, this is your R squared value, and this right here is called the standard deviation of the residuals. So if I was to see part A right there, what is the equation of the least square regression line that describes the relationship between row and test score? I would write score hat equals 85,706 minus 1.1171 times row. And I've done all that they asked. I identified the equation, I defined my variables. That hat above the score looks kind of funny. I'm going to rewrite that. I don't know, it didn't look like a hat. It looked kind of like an arch. So there we go, it's a little better. On part B, they want us to interpret the slope. And slope in this case is negative 1.1171. When I do this, I'm thinking rise over run. I don't have a fraction, so force it to be a fraction. Put it over 1. Remember, it's change in y over change in x. So change in score over change in row. And if you see that, that's change in y over change in x, like you learned all the way back in Algebra 1. Now just put it into a sentence. There is a decrease of 1.1171 in score for every one row. Correlation, that's R, but I don't see R in the data output. I do see R squared. That's 0.047. So let's square root that and we got it. So square root of that is 2168. Although be really careful. What did we just get done saying on part B? Slope is negative. So throw a negative on it. You know, back in Algebra 2, when you say plus or minus, we have to ask ourselves, okay, we just created the square root sign. Is it a positive or a negative? And in this case, it's a negative relationship, so make sure you write negative. So on the quiz last week, hopefully you said something like row, and I need a different color. This is too much red. Row and score have a negative, moderate, linear correlation. All right, let's look at interpreting standard deviation of the residuals. The standard deviation of residuals, as you see in the box, is 10.0673, and that's like an average prediction error. So I would say something like, on average, the predicted score is off by 10.0673. R squared, we did that on a previous video, but it's 0.047. So I would say 4.7% of the variation in score. Remember, it's variation in Y, so in this case it's score. Is explained by a linear relationship with rho. And lastly, let's say whether or not the linear model is appropriate, and I would say no. Rho and score do not appear to be linearly related. And I'm going to lead with the scatter plot. Because the scatter plot does not have a linear pattern and even though R is moderate, it's like just on that borderline of being weak. So, I mean, you could get away with just saying correlation is not strong. Barely fit that on that page. All right, please let me know if you have questions. That's the last video. I will see y'all later. Bye.